What if I told you that something just changed beneath the United States? Not years ago, not last month, but right now. No explosion lit up the sky. No emergency alert buzzed your phone. No breaking news banner warned you. Yet deep underground, far below highways, homes, and entire cities, the ground itself shifted. America's most dangerous fault line, a fracture that has shaped history and erased cities, just moved. And the people who monitor this kind of movement for a living, they didn't celebrate. They didn't shrug it off. Instead, they used words they almost never use lightly. Unusual, accelerating, concerning. These are not headlines written for clicks. These are terms pulled straight from scientific monitoring rooms. The kind of rooms where silence usually means everything is fine. But this time, the silence broke. Because when a fault line moves in the wrong way, at the wrong location, and at the wrong speed, it doesn't always end quietly. Some experts are now watching a narrow window of time, a window measured not in years, not in months, but in hours and days. A 72-hour period where the risk equation changes, where probability shifts, where history has shown that the Earth sometimes decides to release what it's been holding back. This does not mean disaster is guaranteed, but it does mean the rules of normal have temporarily changed. So stay with me, because by the end of this video, you'll know what exactly moved, why scientists are suddenly on edge, and what the next 72 hours could mean for millions of people living above ground that never truly sleeps. This isn't just any crack in the Earth. This is the San Andreas Fault, the most closely watched, most feared fault line in the United States. It stretches for more than 800 miles from Northern California down past Los Angeles, cutting straight through the state like a loaded blade buried underground. Millions of people live directly on top of it, drive across it, sleep above it, build cities over it, and most never think about what's happening below their feet. This fault marks the violent boundary between two enormous tectonic plates, the Pacific Plate and the North American Plate. These plates are not calm, they are not gentle. They move in opposite directions, grinding past each other at the speed your fingernails grow. But here's the danger. They don't move smoothly. They lock. When they lock, energy doesn't disappear. It builds. Pressure stacks year after year, decade after decade, like a massive spring being compressed deep underground. The longer it stays locked, the more violent the release. And when that release finally happens, the ground doesn't just shake. It rips. Roads split open. Buildings lose their footing. Entire neighborhoods can shift in seconds. History has already shown what this fault is capable of. Past ruptures didn't just damage cities. They rewrote maps, displaced thousands, and changed how America thinks about natural disasters. That's why scientists don't casually talk about movement on this fault. Every millimeter matters. Every change in behavior matters. Because when the San Andreas stirs, it's never meaningless. It's either releasing pressure or reminding us how much power is still waiting below. And right now, that's exactly why experts are paying attention. Over the last few days, something unusual appeared on seismic monitors across California. Not a dramatic spike. Not a quake strong enough to wake anyone up. Not even a tremor you could feel standing still. But to scientists watching the data in real time, it was impossible to ignore. The instruments showed fault creep acceleration. In simple terms, this means the fault didn't suddenly break. It didn't snap or jolt. It slid, slowly, silently, almost politely. The kind of movement that happens deep underground, far below human senses, but crystal clear to sensitive monitoring stations. According to researchers working with the United States Geological Survey, fault creep can sometimes be a good thing. In certain areas, slow movement can release pressure, acting like a safety valve that reduces the chance of a violent rupture. But here's the problem. That's not always how it works. In some cases, fault creep is not a release. It's a signal, a sign that stress is redistributing, a sign that locked sections nearby may be absorbing even more pressure, a sign that the system is changing its behavior, and this is where scientists became uneasy. Because this movement didn't happen in a harmless zone. It occurred in a locked segment of the fault near regions historically linked to major destructive earthquakes. That combination is rare. Locked segments are supposed to stay still. When they don't, it means something has changed underground. Energy may be shifting, stress may be migrating, and the balance that held for decades may no longer be stable. This doesn't mean a major earthquake is guaranteed, but it does mean the fault is no longer behaving normally, and when a system as powerful as the San Andreas changes its behavior, scientists stop assuming and start watching very closely. Let's be very clear about one thing first. No scientist on Earth can predict the exact time or place of an earthquake. There is no countdown clock, no button that says event confirmed. But there is something experts quietly watch for. Something rarely discussed outside scientific circles. It's called a short-term escalation window. When a fault behaves abnormally, when it moves in a way it hasn't in years or decades, the internal stress balance of the system changes, and during that change, the probability of a larger seismic event can temporarily rise. Not forever, not even for long, usually for hours to a few days. This is why timing matters. After unusual movement is detected, scientists pay close attention to what follows. They look for clustering, they look for acceleration, they look for silence that feels too quiet. Because historically, when major earthquakes do follow warning signs, they often occur soon after, not weeks later. That's where the 72-hour window comes from. It's not a prediction, it's a heightened observation period. A span of time when the fault system is considered unstable, when the underground stress may still be adjusting, and when a locked section could either settle or suddenly release. This is why some geologists are watching the next 3 days so closely. Not because disaster is guaranteed, not because panic is justified, but because if something does happen, statistics show this is when it's most likely to occur. And in earth science, even a small increase in probability is taken seriously, especially when millions of lives and critical infrastructure sit above the line. The ground doesn't give warnings in plain language. It whispers through data. And right now, those whispers are just loud enough that experts aren't looking away. If the worst-case scenario were to unfold, the impact wouldn't be limited to one city or one moment. It would ripple. Experts are watching areas across Southern California, through parts of Central California, and along the critical infrastructure corridors that connect Los Angeles, San Francisco, and everything in between. These regions aren't just population centers, they're lifelines. They carry power, they carry water, they carry fuel, they carry data. If a major rupture were to occur, the danger wouldn't look like a movie scene with instant collapse everywhere. Instead, it would arrive in layers. Power grids could shut down as substations trip offline. Highways and bridges could fracture, isolating communities. Gas and water lines could rupture beneath neighborhoods. Cell towers and internet hubs could lose connectivity. Not chaos all at once, but cascading failures. One system falters, then another depends on it, and suddenly a manageable problem becomes a regional emergency. Hospitals rely on power. Emergency response relies on communication. Supply chains rely on transportation. When those links break, recovery isn't measured in minutes. It's measured in days, sometimes weeks. And here's the detail that matters most. Millions of people live directly on or near this fault line. They commute across it. They build homes on it. They raise families above it. For most, the fault is invisible until it isn't. That's why scientists don't just think in terms of shaking intensity. They think in terms of resilience, how quickly systems can adapt, how fast help can move, and how prepared communities are before the ground ever moves. Because when the earth shifts, it's not just the land that's tested, it's everything built on top of it. Here's the line that separates fear-bait from reality, and it's an important one. No scientist is standing in front of a camera saying, "An earthquake will happen." No official alert has been issued. No evacuation orders. No dramatic countdown clock on television screens. That's not how real science works. What scientists are saying is far more measured and far more serious. This movement is abnormal enough to watch closely. That single sentence carries weight, because in earth science, normal is everything. Most of the time, faults behave predictably. They stay locked. They creep where they're expected to creep. They follow patterns that have been studied for decades. What triggered concern here is that the fault stepped outside those patterns. Not violently, not loudly, but just enough to make experts pause. This isn't happening in news studios or social media feeds. It's happening in quiet monitoring rooms, rooms filled with maps, graphs, and real-time seismic data. Screens flicker with microscopic ground motion. Algorithms compare today's signals with data going back generations. And experienced geologists, People who have spent their lives studying this fault notice when something feels off. They don't use dramatic language, they don't speculate publicly, they simply watch, because they know what this fault has done before. The last time the San Andreas released a major rupture, it didn't just crack pavement. It reshaped landscapes, it displaced communities, it forced entire cities to rebuild from the ground up. That history is always present in the data. So when scientists grow quiet and attentive, it's not hype, it's respect for a system powerful enough to stay still for decades and then change everything in seconds. Let's reset the tone here, because this part matters. This is not about fear, it's not about doom scrolling, and it's definitely not about panic. This is about awareness. Earthquakes don't reward panic, but they do reward preparation. And the difference between chaos and control often comes down to what you already know before the ground ever moves. If you live in a seismic zone, preparedness is not extreme, it's practical. Start with the basics. Know where to take cover. During strong shaking, you won't have time to think. Identify safe spots now, under sturdy furniture, against interior walls, away from windows and heavy objects that could fall. Have emergency water and supplies ready, not for months, not for weeks. Even 72 hours of water, non-perishable food, flashlights, batteries, and basic first aid can make a critical difference if utilities go down. Keep your phone alerts enabled. Emergency notifications exist for a reason. They can provide seconds or minutes of warning, updates on aftershocks, and instructions when systems are under strain. Understand evacuation routes and meeting points. If roads are damaged or communication is limited, knowing where to go and how to reconnect with loved ones reduces confusion when clarity matters most. And here's the most overlooked step of all: mental readiness. Prepared people don't freeze as easily. They recognize what's happening. They act instead of guessing. Preparedness doesn't mean expecting the worst. It means knowing what to do if the unexpected happens. There's a huge difference. One leads to anxiety, the other leads to confidence. Most earthquakes cause disruption, not catastrophe, and the people who recover fastest are the ones who planned calmly, not frantically. So take a moment, check what you have, review what you know, because awareness gives you options, preparation gives you control, and in moments when the earth reminds us who's really in charge, control, even a little of it, is one of the most powerful tools you can have. Right now, the ground beneath America is quiet. There are no alarms, no shaking windows, no visible signs that anything is wrong. But quiet does not mean still. Deep below the surface, the movement has already happened. The shift has already occurred. The data has already been captured, measured, and analyzed. And right now, scientists are watching, not with panic, not with speculation, but with focus. Because in earth science, once movement is detected, you don't look away. Whether the next 72 hours pass quietly, as just another moment where nothing follows, or whether they become a page in history books, no one can say with certainty. And that's the calm truth. Nature does not work on schedules. It doesn't announce intentions. It doesn't explain itself in advance. The planet doesn't send press releases before it moves. What it does instead is leave signals, tiny shifts, subtle changes, patterns that only make sense when you know how to read them. Right now, those signals are being read. This moment is not about fear, it's about perspective. Human history is full of reminders that the ground beneath us is not as permanent as we like to believe. Cities rise, civilizations grow, and beneath it all, the earth continues doing what it has always done. Moving, adjusting, rebalancing. Most of the time, nothing follows. Sometimes, something does. The difference is never obvious in advance. So the smartest response is the simplest one. Stay informed, stay grounded, stay aware of the world you live on, not just the one built on top of it. Knowledge doesn't cause panic, ignorance does, and awareness doesn't make disasters happen. It helps people respond when they do. If this breakdown helped you understand what's happening beneath the surface, share it, not to spread fear, but to spread clarity. Because awareness moves faster than rumors, faster than panic, and yes, faster than earthquakes ever do.